One of the problems about the current usage on the ISS is there's a lot of stuff that is vented, specifically nitrogen, and most of their stuff is a mechanical or a chemical to keep that closed loop system running. For air, they use desiccant beds, as well as zeolite and rehumidification, as well as O2 replenishment via water electrolysis. And then recently they had a Saboteur system to treat some stuff that they previously vented, which they can treat water and CH4. They treat the water through a further process to actually make it cleaner, but then they still vent the CH4. And they also vent most of their trash, either to send it back on resupply shuttles or vent feces to burn up in the atmosphere. And the problem with this is it's too much reliance on periodic supply, which is not feasible at all for a long-term mission. And so some of the potential solutions is one of the first ones is a compost and dry desiccating toilet. Pretty much what this does is you have a place where you can separate solids and liquids from human waste, and you essentially leave the human feces in there to get rid of all the harmful pathogens and such, so it can be later revitalized and used for back in the space system for whatever you need it for, and take the actual nitrogen from them. And some things that you can potentially do to speed up this process, because it is rather long. Sometimes it can range from 16 months to 2 years for it to be entirely clean. But if you want, you can increase the temperature, you can store it for longer if you can't do any of the other things, increase the pH. And one thing you also want to focus on is having some type of thing in there to absorb moisture to keep, because it'll break down much quicker with less moisture. And one of the other solutions is you can do any type of these. And so for biological, you essentially will have some type of biological agent that will go through this nitrogen cycle for you, so you can actually end up reusing the nitrogen. And then for the physiochemical, you just end up replacing most of that with some type of way to break it down, either with what they talked about was a boiling water, because it can break down much quicker in there, with other agents in there as well. And then for nitrification, you can have some, if you have plants, which would be the best, like a good way to absorb some of the nitrogen, as well as put that back into the system. You can combine it with the biological to then have the biological breakdown some of the nitrogen, and then have the plants absorb some of it and actually use that in the system. And it'll just keep going back and forth. And so one thing, we can replace the urine recovery assembly and portable water assembly and the shipping of human feces. You can replace it with the microbiological fuel cell, which we talked about earlier, which can actually filter any human excrement. And you can combine that with the compost, so you can actually treat it before it gets in there, and then have it treated further, just to make sure it's more safe. And one of the things I looked at was a algae reactor to actually reuse the air, so we don't have to have a mechanical system for that. So we can replace the Saboteur system and the air revitalization. And so what you do is you end up having some microbiological agent absorb the water and potentially urine, as well as CO2, and they can turn that into oxygen that you can use, and then put the CO2 back in the system. And one big bonus about this is you can actually potentially use this as food or food supplements, depending on how big the reactor is. And a big bonus, especially for long-term missions, is this system doesn't take that long. It can, instead of growing food where it can be like 6 months until you can actually harvest it, this could be like a week. So you can end up having a quick food source. Some problems with this, with the microbiological fuel cell, we really need some innovation in this, and there's some potential solutions with this, but these are some things to think about if y'all want to try and help us come up with better solutions to further make the microbiological fuel cell better. And so just an overall, the pros and cons of this, it can decrease the need and cost to deliver the actual supplies and hopefully cut down it all the way, so you don't need to have resupply shuttles at all. And that in turn makes space travel much more feasible in the long run. And you should be able to reuse most or all waste substances and actually reuse the nitrogen that was previously vented in the gases. And overall, in the microbiological fuel cell in the Agile reactor can actually be used as a food source, which can help a lot with supply, as well as, but one of the cons is you need to worry about the biological aspect of the system. But with our design, that's already incorporated into it through the materials, which will cut down on radiation, and so you won't have to worry about that part.